Biomimetics. One cloudless midsummer day, Andrew Parker, an evolutionary biologist, knelt in the baking red sand of an Australian desert and gently placed the right back leg of a thorny devil into a dish of water. The thorny devil, a small lizard that has learned to survive in the baking heat of the Australian desert, has a secret that fascinated Parker. "Look, look," he exclaimed. "Its back is completely drenched." Sure enough, in less than a minute, water from the dish had traveled up the lizard's leg, across its skin, and into its mouth. It was, in essence, drinking through its foot. The thorny devil can also do this when standing on damp sand, a vital competitive advantage in the desert. Parker had come here to solve the riddle of precisely how it does this, not from purely biological interest, but with a concrete purpose in mind: to make a device to help people collect water in the desert. From natural wonder to useful tool. Parker is a leading scientist in the field of biomimetics, applying designs from nature to solve problems in engineering, material science, medicine, and other fields. His studies of the body coverings of butterflies and beetles have led to brighter screens for cell phones. He sometimes draws inspiration from nature's past. While visiting a museum in Warsaw, Poland, he noticed a 45-million-year-old fly trapped in amber and observed how the shape of its eye's surface reduced light reflection. This shape is now being used in solar panels. As the next phase in his plan to create a water collection device inspired by the lizard, Parker sent his observations and experimental results to Michael Rubner and Robert Cohen, two colleagues at the Massachusetts Institute of Technology. On the one hand, Parker is full of inspiration and enthusiasm about the many possibilities of biomimetics. On the other, Rubner and Cohen are much more practical and focus on the ideas that actually have a chance of being applied successfully. This combination of biological insight and engineering pragmatism is vital to success in biomimetics and has led to several promising technologies. Though Rubner and Cohen are certainly impressed by biological structures, they consider nature merely a starting point for innovation. Cohen says, "The natural structure provides a clue to what is useful, but maybe you can do it better." Ultimately, they consider a biomimetics project a success only if it has the potential to make a useful tool for people. "Looking at pretty structures in nature is not sufficient," says Cohen. "What I want to know is, can we actually transform these structures into something with true utility in the real world?" Unlocking nature's secrets. The work of Parker, Rubner, and Cohen is only one part of a growing global biomimetics movement. Scientists around the world are studying and trying to copy a wide variety of nature's design secrets, with the goal of using them to create something useful. In the United States, researchers are looking at the shape of humpback whale fins in order to improve windmills that generate electric energy. The shape of the body of a certain fish has inspired designers at Mercedes-Benz to develop a more efficient car design. By analyzing how termites keep their large nests at the right temperature and humidity, architects in Zimbabwe hope to build more comfortable buildings. And in Japan, medical researchers have developed a painless needle that is similar in shape to the proboscis of a mosquito. The bio-inspired robot. Potentially, one of the most useful applications of biomimetics is the robot. Robots can perform tasks that might be too boring or dangerous for humans, but such robots are extremely difficult to build. Professor Ronald Fearing of the University of California is creating a tiny robot fly that can be used in surveillance or rescue operations. Fearing's fly is a much simplified copy of the real thing. Some things are just too mysterious and complicated to be able to replicate, he says. It will still be years before his robot fly can perform anything like an actual fly, but Fearing is confident that over time he will close the gap between nature and human engineering. At Stanford University in California, Mark Cutkosky is working on a robot gecko. As long ago as the 5th century BC, the Greek philosopher Aristotle was amazed at how this small lizard can run up and down a tree in any way, even with the head downward. Cutkosky studied the extremely small structures on the gecko's feet that allow it to run up and down vertical walls as easily as humans run down the street. he applied what he learned to create StickyBot, a robot that can walk up and down smooth vertical surfaces made, for example, of glass or plastic. The U.S. military, which funds the project, hopes that one day StickyBot will be able to climb up a building and stay there for days, monitoring the area below. Kwiatkowski hypothesizes a range of non-military uses as well. "I'm trying to get robots to go places where they've never gone before," he says. For now, StickyBot only climbs very clean and smooth surfaces quite slowly, quite unlike a real gecko, which can run up just about any surface very quickly. However, despite the promise of the field and the brilliant people who work in it, biomimetics has led to surprisingly few business successes. Perhaps only one product has become truly famous: Velcro, which was invented in 1948 by Swiss chemist Georges de Mestral, who copied the way seeds called cockleburs stuck to his dog's fur. Some blame industry, whose short-term expectations about how soon a project should be completed and become profitable conflict with the time-consuming nature of biomimetics research. But the main reason biomimetics hasn't yet been a business success is that nature is inherently and unimaginably complex. For the present, engineers cannot hope to reproduce it. Nonetheless, the gap with nature is gradually closing. Researchers are using more powerful microscopes, high-speed computers, and other new technologies to learn more from nature. A growing number of biomimetic materials are being produced. And although the field of biomimetics has yet to become a very successful commercial industry, it has already developed into a powerful new tool for understanding nature's secrets.
4b. Dreamweavers. Alex Souza is a young and extremely creative Danish fashion designer. He says his ideas come to him in dreams. "I daydream. That's how I get ideas." One of his inventions, a jacket that stays suspended in the air like a balloon after it is taken off, arose from such a daydream. He explained, "I was on the subway and this picture of a floating jacket popped into my mind." Alex Souza is one of many dreamers and pioneers who are turning textile fantasies into realities. Thanks to them, the world of high-tech textiles is an exciting place to be these days. High-tech textiles. Not so long ago, all fibers used to make textiles came from natural sources: wool from the hair of sheep, cotton from the cotton plant, silk from silkworms. The first true synthetic fiber didn't appear until 1935, when scientists at the DuPont Company invented nylon. Nylon is just one of various industrially produced substances called polymers. Polymers can be pulled into a thread, which makes them well suited for use in textile manufacturing. Synthetic textiles have come a long way since nylon. Kevlar, a textile which is stronger than steel, is used in bulletproof vests and ropes used by astronauts in space. Other high-tech fibers can resist very high temperatures, perfect for firefighters and race car drivers. While not all companies are forthcoming about their products for fear of having their ideas stolen, Hugues Vinchan, an executive at Dubar Warrenton, a manufacturer of high-tech textiles in France, is happy to display some of the amazing synthetic fibers his company creates. There is an oil-eating textile that absorbs 5 times its weight in oil and is perfect for cleaning up oil spills. Another absorbs vibrations. "Can you imagine a motorboat you can't hear?" he says. There is also an ordinary-looking cloth bag that is completely water-soluble, according to Vinchan. "It's strong enough to carry heavy objects, but if I dip it in boiling water, it disappears." Some high-tech textiles draw their inspiration from nature. Spider silk is a natural fiber that is 5 times as strong as steel. Unfortunately, spiders cannot be farmed, as they will eat each other. A Canadian biotechnology firm, Nexia, has come up with a possible alternative to spider farming. They have inserted the spider silk protein gene into goats, thereby causing them to produce spider silk protein in their milk. Nexia's head, Jeff Turner, is already dreaming of applications for the new fiber, named BioSteel. Why use rockets to lift objects into orbit? Why not have a big satellite and dangle a rope down to Earth and pull them up? There's not a rope that will hold its weight at that length, but spider silk, with its high strength-to-weight ratio, could. Wearable electronics. Textiles have always been used in clothing, and modern, high-tech textiles may redefine what clothes are all about. In the past, clothing protected us from the elements, says Ian Scott, head of technology for women's wear at British department store Marks & Spencer. Then clothing became about fashion. The future is about clothing that can do something for you. It's no longer passive, it's active. One example of this active clothing that he hopes to sell in the next few years is an intelligent bra, a sports bra that can sense stress and adjusts its dimensions to give perfect support. Other wearable electronics are being pioneered at a design laboratory in London, run by the European manufacturer Philips Electronics. They are in the planning stages for various high-tech products, including an intelligent apron. This electronic apron acts as a kind of remote control device. It has a built-in microphone that allows the wearer to operate kitchen appliances using voice commands. Another planned product is the Queen of Clubs outfit. According to a Philips spokesperson, here's an outfit for the girl who's really into clubbing. Sensors hidden in her clothes allow her to affect the lights and beat of the music, so that she can make contact with other people across the dance floor. She has pants with lights that flash when someone is trying to get in touch. While there are many interesting clothing innovations to look forward to, the only item so far sold in stores was marketed a few years ago as the first wearable electronics jacket. The jacket, called the ICD Plus, sold for about $1,000. It had an MP3 player and cell phone. Headphones were built into the hood, and it had a microphone in the collar. Clive Van Heerden, director of Intelligent Fibers, pointed out that it was an early first step and a conservative one. We want to make the jacket that makes the coffee and picks up the kids and keeps track of the shopping list, but it's not going to happen overnight. Future warriors. One of the most important areas of clothing innovation is for military purposes. High-tech textiles are everywhere at the U.S. Army Research Center in Natick, Massachusetts. As part of their Future Warrior program, researchers are developing uniforms that will make a soldier difficult or impossible to see. Fibers in the uniform would take on the same color, brightness, and patterns of the surroundings of the wearer. A soldier dressed in such a uniform would become nearly invisible to the enemy. The researchers at Natick are also working on portable buildings that are made of what are essentially large, high-strength textile balloons. Called air beams, these building materials would allow a team to build a structure large enough to hold airplanes in a fraction of the time a conventional metal structure would take. The largest air beams, about 0.75 meters, 2.5 feet, in diameter, and 24 meters, 78 feet, long, are so rigid that you can hang a heavy truck from one. Yet they can be packed into a truck. Whereas a conventional metal hanger takes 10 people 5 days to set up, one made of air beams can be set up by 6 people in just 2 days. Today's textile innovators are creating astonishing things. From Alex Souza's artistic jacket that defies gravity, to smart aprons, to invisible military uniforms, high-tech textiles will soon be appearing in more and more parts of our lives. Who can foresee what these textile pioneers will dream up next? It's about imagination, says Alex Souza with a bright look in his eye. It's a beautiful dream. It's turning science fiction into scientific fact.